السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. نرحب بكم من منصة البث المباشر وزارة التربية والتعليم جمهورية مصر العربية. معكم مستر حسام حسن مع تحيات فريق المنصة بالتوفيق والنجاح بإذن الله. مع حلقة الكيمستري النهاردة، طبعا احنا كما تعودنا ان احنا دايما بنبتدي بحاجات القديمة اللي احنا بنشتغلها. طبعا احنا في السيشنز اللي فاتت اتكلمنا عن ال properties of periodic table، وبدأنا بالatomic radius، وبعد كده اتنقلنا إلى ionization potential، وطبعا عرفنا ال graduations of ionic potential والatomic radius، وعجبنا relations between atomic radius and ionic and ionic potentials or potentials of this energy which express about the ionic potential. Electron or electronegativity غير ionization potential. ionization potential ديت بتركز على الانرجي absorbed، يعني هنيجي نلاحظ هنا ان الاتوم بتعمل ايه؟ gain energy and this energy it efficiency or sufficient for removing the farthest electron in the atom. خدنا الالكترون افينيتي، قلنا الالكترون افينيتي برضو بتعتبر ايه؟ الانرجي ريليزد. طيب انا هنا هنتكلم عن electronegativity concepts. Electronegativity concepts ability of atoms to attract sponge electrons. ايه هنا الكلام كله على ايه؟ على الالكترون in the bonds. هي بتعتبر similar للالكترون افينيتي. الالكترون افينيتي كانت بتتكلم عن الايه؟ كانت بتتكلم عن الانرجي ريليزد when the atom gain one or more electrons in the farthest principal level or the farthest sub level. هنا الالكترونيجاتيفيتي بتتكلم عن ايه؟ عن الابيليتي تو atoms او الابيليتي اوف atoms to attract bond electrons. دي بتاعت مين؟ دي بتاعت حاجه اسمها الكوفالنت بوند. الكوفالنت بوند طبعا بتتكون between two or more atoms and each atom share by number of electrons similar another atom. So between two atoms, if they attracts these electrons between them, and the electron pass through from the other atoms, from atom to another atom. Because this covalent bonds, we have a difference between two atoms in electronegativity. So electronegativity of atoms or elements is expressed by values indicating that an increasing in these values corresponds to an increase in their relative chemical ability to attract bonding electron. معناها ايه؟ معناها مثلا لو انا عندي two bonds or one bond، خلينا نتكلم على one bonds between N and H. N related with hydrogen. Hydrogen have small electronegativity and nitrogen have high electronegativity. So nitrogen have an ability greater than hydrogen to attract these electrons. So nitrogen have negative partial. This negative partial expresses that the attractive force of nitrogen is more than hydrogen. So the electrons concentrated to nitrogen because nitrogen is more in electronegativity. So the electronegativity, it is the ability of an atom to attract bonding electrons towards itself when it is parts of this compound. We have an example, fluorine in most electronegativity elements, which means it strongly attracts bonding electrons. This electronegativity used in determinations of the type of bond between atoms, covalent or ionic bonds. If the difference between the two atoms more than 1.7, so these expressed by ionic bond. If the difference between two atoms equal less than 1.7, so we can call it as covalent bonds. We have normal or pure covalent bonds and polar covalent bonds. Polar covalent bonds have the differentiations between less than 0.7 and more than 0.4. So based on the difference in electronegativity between these atoms in the compound. Now we have electron affinity. I illustrate the electron affinity before, but now we can to illustrate this and again. Definition: it is the amounts of energy released. أنا اختلفت أهو. التاني هنا attraction force between two atoms in this bond. لا دي in gaseous state مفيش هنا bonds. هنا the definitions بتقول إيه؟ It is the amount of energy released when a single atom in its gaseous states gain an electron or more to the form of negative ion. يبقى هنبص هنا في الديفينيشن هنا هو شبه الديفينيشن هنا بس الديفينيشن هنا عبارة عن expressions about what about electronegativity or about the attraction force, ability to attract. But here this concepts of energy, but this energy is released from the atom when it gain one or more electrons in the farthest sublevel. So form this negative ion which forming by this gaining of electrons. يبقى هنا حصل gaining of electrons. When it gain one or more electron, it release a quantity of energy. This is quantity of energy called electroaffinity. We have an example: chlorine has a high electronegativity, which means it's release a large amounts of energy when it's gain an electron usage. Electrons affinity is used to understand how readily an amount can gain an electron and form a negative ion. Simply, but electronegativity relates to atoms to chemical bonds, pertains to individual atoms to their gaseous state. يبقى بنيجي نلاحظ هنا ان بنيجي نتكلم عن electronegativity تختلف تماما عن الالكترون افينيتي. electronegativity inside the bonds or inside the molecule, but electron affinity in the electroaffinity in the gaseous state of atom. Gaseous state of atom. Okay. Now table of electronegativity, and we want to do the graduation of the electronegativity and electron affinity in the period or in the groups. We discuss here this a section. This is a section of a periodic table. We have groups and the period. This is period 1, 2, 3, 4, 5, 6, 7. And we have a group 1, 2, 13, 14, 15, 16, 17, or 1A, 2A, 3A, 4A, 5A, 6A, or 7A. We have some values. We want to study these values and conclude the graduations of electronegativity of each atom in the periodic table. We study number 1A, hydrogen 2.2, lithium 0.98, sodium 0.93, potassium 8, 0.82, and rubidium 0.82, cesium 0.79, and francium is 0.7. We have these values is decreases in the direction from up to down. So I can call this graduation by increasing atomic number in this direction. The electronegativity decrease in this direction by increasing the atomic number in one group. We have group 2A. 2A starts with beryllium because as 1s2 as helium is noble gas. We study representative elements only. احنا بندرس هنا representative elements only. And representative elements starts with beryllium 1.57 and next magnesium 1.31, calcium 1, strontium 0.95, barium 0.89, and radium 0.9. So the same, by increasing atomic number from up to down in the same group, we find that the electronegativity decrease. And so on in the next group. We study the graduations of electronegativity in each group separately. Okay, we transfer the study of the graduations of periodic in the periodic table in the one period from sodium, example from sodium to chloride. Sodium to chloride. Okay. Sodium equal to 0.93, magnesium 1.31 increase, 1.61 aluminum, 1.9 is silicon, phosphorus 2.19, sulfur 2.958, and chlorine 3.16. We find by increasing atomic number in from the left to right sides in the one period, we conclude that by increasing atomic number, the electronegativity increase too in this direction, okay? And period 5, you show that the same, increasing the periodic table in the period, we find increasing of electronegativity in this direction. I want to explain this group, exactly this group 7A, halogens. Fluorine 3.98, chlorine 3.16. So fluorine is the most elements in the electronegativity. Review all numbers here, we find 3.98 is the highest electronegativity. Fluorine already have a negative one when it reacts with another atom. Okay. Now we study the graduation of electronegativity, and we wanted to conclude during the period. We repeat the studying here by writing it. By increasing atomic number, electronegativity increase. Explanations, we find increasing in nuclear charge. Number of proton increase. So in the period we studied before, in the period by increasing the atomic number, actual nuclear charge increase too, and the effective nuclear charge increase. We move from one element to another within the same period. The atomic number increase, meaning the number of protons in the nucleus increases. The increases in nuclear charge attraction the electrons more strongly towards the nucleus because the effective nuclear charge increase too, and number of principal level is constant, doesn't increase. So the number of electrons only increases in these principal levels. So the electron, so the effective nuclear charge increase and the attraction force increase. So the electronegativity increase by increasing the atomic number in the same period, in this period. The graduations of electronegativity, decreasing in atomic radius. Number 2, decreasing in atomic radius. With the increase in nuclear charge, the increasing of nuclear charge, electrons are pulled more strongly towards the nucleus, reducing the atomic radius This brings outer electrons closer to the nucleus. So the atoms have increasing the nuclear attraction for these electrons. So the electron negativity increase in this direction. Stability of energy level. You have an stability of energy level. In the same period, the outer electrons remains in the same energy level, same stable. The same period, the outer electrons remain in the same energy levels. However, with increasing in nuclear charge, they are attracted more strongly towards the nucleus without a significant increase in electron and electron repulsions. We conclude from this stability, we find that results in the electronegativity of electrons increase as we move from left to right. We discuss the period now. And we discuss some factors. These factors affects on nuclear charge and effective on the electronegativity values due to increases the effective nuclear charge and the decreasing in atomic radius, leading to strongly attraction of electrons towards the nucleus. Okay, now we transfer, we have this arrow electronegativity increase in this direction by increasing atomic number. This is a direction of the period. We transfer to the graduation electronegativity in one group. Now we write this increasing of atomic number electronegativity decrease. Why? We must explanations here because number one, decreasing in effective nuclear charge. Now, we studied before the effect of actual nuclear charge and number of principal levels, but in the same group, we saw number of principal level increase. The number of principal level increase and the electron repulsions increase, so we have many principles between the nucleus and the farthest electrons. So the effective of nuclear charge will decrease in this direction. As we move from one element to another within the same group, the atomic number increase, okay? Which means the number of energy levels in these atoms also increase. This is increasing affects increasing of the number of energy levels, reduce the effective nuclear charge, resulting in weaker attractions of electrons towards the nucleus, towards this nucleus. Number two, increasing in atomic radius. Atomic radius increase by increasing the atomic number in the same period from up to down, with decreasing in effective nuclear charge. These electrons are pulled less strongly towards the nucleus, which increases the atomic radius. This makes the outer electrons farther from what? From the nucleus, reducing the nuclear attraction for these electrons. When the electron increases from up to down, we find the increasing of atomic size or atomic radius. So the electronegativity in this direction decreasing, not increasing. Now we study the differentiates between the period graduation on electronegativity and group graduation in the electronegativity, and we conclude that fluorine is the greatest number or greatest value of electronegativity. Increases in energy levels. This is the regions for this decreasing of electronegativity. In the same group, the positive of the outer electron charge or changes as they occupy higher energy levels. However, with the decreasing in the effective nuclear charge, they are attracted less strongly towards the nucleus. And there is a significant increases in electrons, as the electron will repel between them. So, as a result, the electronegativity of electrons of elements decreases as will decrease an effective nuclear charge, leading to weaker attraction of electron towards, and we studied that in the period I illustrate you, but I read these illustrations to you to understand more. We have in the period radius decrease in this direction, so the ionization energy and electronegativity, electron affinity increase in this direction, and vice versa for the group. Now we transfer another address for another things is metals and metallic properties. What the meaning of metal or metallic properties of elements? Metallic properties of elements you studied before in previous school or this stage. You studied the differentiations between metals and nonmetals and metalloids, but you take a little information about metals and nonmetals. Metallic properties of elements. Number one, this metallic properties of elements depends on several conditions and characteristics that distinguish them from nonmetals and metalloids. Here is key conclusions, and we conclude this from this condition. Which condition? Number one, number of valence electrons. Number of valence electrons. You studied before 1, 2, and 3 in the farthest sublevel, so the elements tends to lose these electrons when it reacts with another elements. So we can call this element is a metal. Metals typically have 1, 2, 3 electrons in their outer shell or outer energy levels or valence shell. This makes them tends to lose these electrons to form positive ions. To form positive ions. These positive ions, it is tended to make what? To make ionic bonds with another atoms. Number two, electrical and thermal conductivity. Metals are good conductors of electricity and heat due to the presence of free electrons. Sodium, potassium, magnesium, copper, zinc, and so on of any metals is conduct electricity. Iron conduct electricity. Copper very good in conducting electricity and heats. Aluminum, so it is very conductive of electricity. So it is concentrated in 1, 2, and 3A groups. These metals are good conductors of electricity and heat due to have they have free electrons. These free electrons help this metal to conduct electricity from place to another. Through the crystal lattice of the metals, we find it is easy to conduct electricity by using tools, see on cooking or another things in our life. Metals have a luster and shine. Luster shape and shine shapes. Metals are characterized by shiny and lusters. Luster shapes. This surfaces when is the polished you find is a luster. لها شكل لامع. تمام؟ تعتبر lustered. تمام؟ نيجي بقى هنا حاجة اسمها malleability and ductility. What the meaning of malleability and ductility? You can rechange the shape of metals by using this property. Metals are typically ductile, meaning they can be drawn into wires, and malleable, meaning that can be hammered into sheets without breaking. It is carried out anything about that by your hammer. It is very carried principles for many industries because it is high melting and boiling point. Metals generally have relatively high melting and boiling points because it is have a metallic bond. Next term, we will study metallic bond and we will illustrate this type of bond, and this is a region for raising of temperatures for boiling points and melting points, which make them solids at normal temperature, except mercury. It is a liquid. Mercury is metal, not non-metal, but it is a liquid in liquid state. If you see a liquid state in this shape, we find it is a liquid, but it is a metal. Atomic radius and ionization energy. Metals are characterized by a large atomic radius and lower ionization energy. And we have chemical reactivity is very active. Metals tends to react with oxygens to form metal oxides and with acids to form salts and release hydrogen gas when it reacts with another acids. Metallic properties, like we saw in these actions, it is needs to make ionic bond by loading these electrons to another atoms. Electronegativity, metals tends to react with nonmetals and lose one electron or more during chemical reactions. Now we find this mercury. All metals are solid except for mercury is liquid, not a solid. Non-metallic properties is the reversible properties for metals. Non-metals are characterized by several properties that distinguish them from metals and non-metals and metalloids. Here is the main conditions of non-metals properties. What is this main condition of it? Non-metals typically have 5 to 7 electrons in their outer shell, like 5A, 6A, and 7A. It concentrated nonmetals in 7A and 6A, 5A, but is very strong nonmetals in 7A, strongest nonmetal in 7A because its nonmetals properties apply in this group. Nonmetals typically have 5 to 7 electrons in their outer shells, valence shell. This makes them tend to gain electrons to achieve a stable electronic configuration, similarly to the noble gas. By gaining these electrons, it is converted into closest noble gas. Electrical and thermal conductivity. Nonmetals are good insulators. Doesn't conduct electricity or heat, except carbon. This is a good conductor, as they are poor conductors because it have no free electrons or electricity and heats due to lack of free electrons that move easily. Non-metal, according to Lucer and Chine, is non-metals, not Luster, Chine, because it's like metals, Lusters, and often have a dull appearance. This is a carbon. It is an example for nonmetals. Nonmetals, malleability and ductility. Non-metals are brittle and cannot be drawn into wires or hammered into sheets, meaning they break easily when attempts are made to shape them. Now, this is the properties of nonmetals. Melting points and boiling points. Nonmetals have relatively low melting points and boiling points because it is makes some them gaseous and normal state, or liquid in normal state, or STP, standard temperature and pressure. like chlorine, fluorine. Bromine is liquid, iodine, carbon is solid, but it is melting point is very low. Chemical reactivity, nonmetals tends to gain electrons to form negative ion in chemical reaction and form covalent bonds with other nonmetals. Nonmetals melting and boiling points. This is a chemical reacted. We show in this reaction it is gain one or more electron when reacts with another element. Physical state. Nonmetals can exist in different physical states. Some are gaseous like oxygen and nitrogen. Some are solid like sulfur and carbon, and some are liquid like bromine. We have different shapes or different states in room temperatures. Non-metallic properties increase in this direction, metallic decrease in this direction. Between them we have non-metals, and metals is metalloids. It's metalloids. What the meaning of metalloids? Metalloids, it is like metals but behave like non-metals. And non-metals concentrated in the right side of this periodic table, but metals concentrated in the left side on the periodic table. We transfers to metalloids. Metalloids like boron, silicon, germanium, arsenic, antimony, tellurium, and this atoms distributed between metals and non-metals. We have boron between small or weak metal. Here is this weak metal. Carbon is weak non-metal. Between them is metalloids. So phosphorus is a weak non-metal. Aluminum is a weak metal. Between them, silicon is a metalloids. And metalloids are elements that have properties intermediate between metals and non-metals. Have intermediate properties. The most widely recognized metalloids includes metalloids have electrical conductivity that's less than metal, but more than non-metals, but it's much greater than non-metal. They are used in the manufacture of parts of electronic devices like transistors, such as transistors due to the properties of semiconductors. Semiconductors like silicon, germanium, and another elements. This is example at the arsenic and the germanium, silicon, and boron. This is the famous metalloids in the periodic table. Boron, silicon, germanium, arsenic, and antimony, tellurium, and polonium. This is an metalloids. These elements are typically found along zigzag. What the meaning of zigzag lines? Because it is not have a place exactly. We have the zigzag places not found in exactly places like non-metals and metals, because it is found in zigzag. It is zigzag lines on the periodic table that separated metals from non-metals. After weak metals and weak non-metals, between them is metalloids. Also in the period or in the group. This is metalloids here. If you study this periodic table, carbon, silicon, germanium, and stannous. This here, stannous and lead. Between carbon and stannous, we have silicon and germanium. Weak. Nitrogen, phosphorus, non-metals. Metalloids, and very weak metals. Oxygen, sulfur, selenium, tellurium between this is polonium. Polonium is a weak metal. So we transfer in these shapes of periodic table. we conclude that it is a zigzag shapes in the periodic table. Now the meeting is over and we will see you later, God willing. Thank you for good listening. والسلام عليكم ورحمة الله وبركاته.